Today we're looking at Prisma ORM with MongoDB, a really useful combo for building database-driven apps. MongoDB is already a great database choice for JavaScript developers with several ways to work with it, from the native driver to Mongoose to type-safe ORMs like Prisma. So why pick Prisma? Well, I've personally used all of these approaches, and I want to share what makes Prisma worth considering for your MongoDB projects. In this tutorial, I'll walk you through a practical workflow for using Prisma ORM with MongoDB. You'll see how to build a full-stack Next.js application and how Prisma Accelerate can make MongoDB performance even better through connection pooling and caching. Now, for context, I've been building web apps for over 20 years, and I'll be sharing practical tips from my own experience. Before we get into the code, let's quickly go over what developers typically get when working with MongoDB. You get a general-purpose, flexible database that adapts easily to your schema changes. Document-based storage that works naturally with JavaScript objects, powerful query options through the aggregation framework, and solid performance across different workloads. Prisma ORM adds these helpful features that work well with MongoDB's strengths. Complete type safety for your database operations. Clear schema management with automatic validations. Simple handling of relationships between collections. And a query engine that creates optimized MongoDB operations. And when we add Prisma Accelerate to the mix, which is a fully managed global connection pool and edge-based caching layer for your existing database, we get these extra benefits. Serverless connection pooling without managing extra infrastructure. Much faster cold starts in serverless environments. Better response times with caching of query results. A global edge distributed caching layer for quicker database access. And less connection load on your MongoDB deployment. Let me show you how Prisma ORM changes MongoDB development by building a simple but complete user management system with Next.js 15 using the App Router, Prisma ORM, MongoDB, and Tailwind CSS with shadcn UI components, of course. If you're looking for some helpful tips and tricks to take into account when working with Prisma ORM and MongoDB, go check out this video. And if you don't see it pop up yet, it'll be coming out very soon. So here's what we'll cover. Setting up MongoDB Atlas and connecting Prisma ORM. Defining our data model for users, posts, and comments, generating Prisma Client, building API routes with Prisma ORM, creating a front end with Next.js and shadcn UI, expanding app functionality with posts and comments, and scaling with Prisma Accelerate. Now, there are some prerequisites. You will need Node.js version 20+, a MongoDB Atlas account, which is completely free, and a Prisma Data Platform account for Prisma Accelerate, which again is completely free. So let's get started by setting up our project. I'm going to create a new Next.js application and add Prisma ORM. So npx create next app, and we'll do that in this directory. We'll just choose all of the defaults. And then let's install as a dev dependency Prisma, and then npx Prisma init. So that's our basic scaffolding for this project. So next we're going to configure our MongoDB connection. Now I've already set up a MongoDB Atlas cluster, and if you haven't done that already, go check out this video to help you get started. You'll need to set up your cluster, make sure that you have a database user set up, your IP addresses added to the network access list, and get your connection string. So if you haven't done that already, go do that and come back. Next, let's update our Prisma schema file. This was created by the Prisma init command. So if we go over to Prisma and schema.prisma file, if you're using VS Code, be sure to install the Prisma extension. It has very nice syntax highlighting along with many other nice features. So by default, Prisma is set to Postgres. So let's change that out to MongoDB. And then be sure to save that file. And then if we go over here, we should have a .env file. And we want to make sure that we replace this database URL here with your MongoDB connection string. So it should look something like this. Be sure to replace username and password with your database username and password. Now pay special attention to this MyDB portion here. This is the database name that the Prisma ORM is going to use. So if the database doesn't exist yet, MongoDB will create it automatically when Prisma ORM first connects. Be sure to save this file once you've updated it. And then let's go back into the schema.prisma file. So with Prisma ORM, you get a clear declarative way to define your MongoDB collections and their relationships. So let's add some data models to this file. So just under the client and DB, we're going to add a user model, a post model, and a comment model. This Prisma ORM schema defines how our data will be structured in MongoDB. Even though MongoDB has a flexible schema by nature, Prisma ORM helps us to maintain consistent data structures in our applications. Now for each model, there is an ID, and the ID has an @ID decorator, which marks this as the primary key field. And then we have at default auto. This automatically generates a MongoDB object ID. And then we map that underscore object ID to ID, because in MongoDB, the default ID is underscore ID and not ID. So that is the reason for this mapping. And then we have at db.objectID. And this specifies the MongoDB specific data type. And then we have specific relationships established between our models. So a user can have many posts and many comments. A post belongs to one user and can have many comments. And a comment belongs to one user and one post. And so relationship fields like post and comments in the user models use arrays. So we've got these square brackets here to indicate that they can contain multiple related documents. And we notice that we have some fields here defined as string with a question mark. This means that this is an optional field. And then we have things like the created at date, which is a date time, and it's set to at default now. So this automatically sets that timestamp on creation. And then update is updated at, which will again automatically update that record when it's updated. Now, the cool thing here is that Prisma ORM will generate TypeScript types from this schema so that we get full type safety when working with our database. It also takes care of setting up the right MongoDB indexes to make sure that these relationships work properly. So let's generate our Prisma client and push our schema to MongoDB using the terminal. So let's go ahead and save this, open up our terminal. So we'll do npx prisma db push. And so this command will create the collections in your MongoDB database, the users, post, and comments collections, set up the appropriate indexes for relationships and unique fields, like the unique index on email, and it will generate Prisma Client tailored to your schema. And we can see all of the things that it did here. Next, we're going to create a shared Prisma Client instance. We're going to use something called a singleton pattern. This is going to prevent multiple database connections in development and ensure efficient connection management in production. So in our root, let's create a new file. We're actually going to create a new folder and file. So it's going to be lib/prisma.ts. So here we'll import the Prisma client. We'll set up a global for Prisma. So this global will be reused in development, and in production, we'll have this shared client for the entire application. So be sure to save this. All right, let's build out some API routes now. And so we're using Next.js, we're using the app router, and so we can use server actions instead of the traditional API routes. These server actions are basically server functions that can be called directly from a component. So let's create these to manage our data in a new file. So here in app, we're going to create a new file called actions.ts. Instead of me typing all of this out, let's paste it in and we'll go over it. So we are using use server. So all of this code will run on the server, even though it's being called from the client component. So we're importing Prisma from our Prisma lib file. We're also going to revalidate the path at certain points. So we've got our read actions. So we're going to get users. So users is going to await prisma.user.findMany. And we're going to include posts in this call. So this fetches all users from the database and includes their posts and their comment counts. Next, we have get posts. We're going to limit that to 5 posts by default. So again, prisma.post.findMany. And so this action fetches the latest posts, including the author and the comment counts. So here we're including the comments and the author. Next, we have get user by ID. So we could just pass in an ID and get that specific user by its ID. Again, including the posts and comments for that user. And then create user. We're going to include the email and the name. And then prisma.user.create, and then send that data of the email and the name. Because we are changing something, we're adding something to the data set, we want to revalidate that path so that it immediately shows up in the UI. Next, we have create post. In this, we're including the title, the content, the author ID, and whether it is published. So we have a check here on the author and the title. If the author does not exist, we'll throw another error. And then here is the actual post creation where we pass in that data, including the author ID. And again, because we're creating that new post, we are going to revalidate that so that it shows up without having to refresh the page. Okay, so then create comment is our last action here. We'll include the content, the post ID, and the author ID, and then we'll just do a check to make sure that the post exists and that the user exists. And if So then we will go ahead and create that comment, including the data for that comment. And so that's all of our server actions. Next, we'll leverage Next.js server components to build our UI. So again, this approach moves data fetching to the server, reducing client-side JavaScript and improving performance. So let's go over to our existing page.tsx file. So I'm just going to replace this existing demo code. And you should see some red squiggly lines here. This is because we haven't created these components yet. That's okay. So in this home component, we are going to get our users and then display our user form and our user list. So let's go ahead and create those components. So in our root, let's create a new folder and file. We're going to call the folder components, and the file is userform.tsx. So this is going to be a use client component. We're going to import several things here from React, some shadcn UI components, which are not installed yet. That's why we got squiggly lines. Use router and create user from our actions. So this is going to be a form. So we've got some fields here that we need to keep track of the state. We have email, name, loading state, and our router. So we're going to handle the user creation here using our create user action that we imported from our server actions, and then reset the form after it's been sent, put up a toast message, and then refresh our router. And then here's all of the markup for the form itself. So let's save that and let's create our last component here for the users, and that is going to be the user list. So in components, let's create a new file here called userlist.tsx. So again, this is going to use client, some shadcn UI components, link, and then user from our Prisma client, because we're going to extend user. We're going to add to it this count, which we're going to use a little bit later. So this new type is going to be used in our interface here called user list prompts. So here's the markup for our user list, which just lists out all of the users. If there are no users, it will say no users found, create your first user. And if so, it will go ahead and list out all of the users along with their post counts and comment counts. So let's save that. And of course, we still have all of the squigglies because we have some shadcn UI components to install. So let's go ahead and do that. Open up the terminal and let's npx shadcn at latest init. And then let's go ahead and add our components. So npx shadcn at latest, add button card input label and sonar. Lastly, we need to set up our sonar component, which is our toast component. Oh, and it looks like I've got a red squiggly here because I misnamed this user lists instead of user list. So let's rename that. And I probably just need to restart my TypeScript server, but let's go over to layout. This will work, I promise. We need to add our sonar, our toast provider into this. So we're going to add another import here for the toaster from sonar. And then just after we return our children here, we're going to also return the toaster component, and we can specify the position. We'll just say top right, that's fine. And now let's go ahead and test out our app. So let's go back into our terminal and npm run dev. Let's open that up on localhost 3000, and yay, it works. So we have our user management system. We should be able to add a new user. So let's do this user at example.com, Jesse Hall, create user. And there we go. We have a new user. All right, next let's make our app do more by adding posts and comments. And this is going to show you how well Prisma ORM handles relationships in MongoDB. So let's first go to our page.tsx file and let's make some changes here. So we're going to add two new components, a post form and a post list, and then also render those down into a new section. All right, so let's save that and let's go ahead and create those new components. So in components, let's add a new component for the post form, postform.tsx. Okay, so this is going to be another use client, and we're going to pull in a bunch of new shadcn components. And again, this is a form, so we have a bunch of fields that we need to keep the state of. And then we have our handle create post, which uses create post from our actions. And then we are resetting our form, putting up our success toast, and refreshing the router, just like we did in the other form. And then here's the actual markup for the form itself. Okay, so let's save that and go ahead and create our other component, which is post list. So post list.tsx. And this will be similar to our user list. We're creating a new type here, post with relations. And then we're also bringing in our comments. And we have a form in here to submit new comments. So here we're using our create comment action. And then here is our markup for that. So be sure to save that. And then in our terminal, we do need to install some more shadcn components. So npx shadcn at latest, add select text area and checkbox. Then we're also using a package called date fns. So let's install that. And then npm run dev, and let's see if it works. Go back to our localhost 3000. Nice, so now we have our users and we have posts. So let's go ahead and create a new post. Awesome title and some awesome content. We'll select our author, and should we publish this immediately? Let's not, and we'll see what happens. So we'll create that, and we have our first awesome title. It's in draft, and we have the content, etc. And then we have comments here, so it shows that there are 0 comments. And if we also move up, we can now see that there's one post associated with this user, so we can see the relationships are working. And let's go down here to comments. We'll click show, and we can add a new comment. This is amazing. And let's post that. And so now I have this new comment here, and then come up here and there's a new comment here. So all of the relationships are working, the posts are working, the comments are working. And let's go over to MongoDB really quick. In MongoDB Atlas in the dashboard, we can see exactly what it did here in the dashboard. So we have this Prisma demo database that it created. We have a comment collection with our comment. We have our post collection with our posts and our user collection with our users. Amazing. Next, let's add Prisma Accelerate to our app. This gives us some nice benefits like connection pooling for serverless environments, global distribution, and faster database access. So first thing, of course, sign up for Prisma Accelerate. It's completely free. Once we are in, go ahead and click New Project. I think the first time you sign up, you'll see this page right away. So go ahead and name your project and then choose your starting product. So go down to Accelerate and get started. And this is where we need to paste in our connection string. So you should still have your connection string from before. So go ahead and paste that in here. Choose a region if you want, and then go ahead and create project. Then we'll need to generate an API key. So click Generate API Key and copy that and put it somewhere safe. Actually, you need to go ahead and paste that into your environment variable file. Once you've done that, click I've securely stored my connection string, and then it has some nice directions here for us after that. And we'll walk through that next. So this is what your env file should look like now. You have your database URL, which points to Prisma Accelerate, and then your direct database URL, which is, again, your connection string directly to MongoDB Atlas. Make sure you save that and close that file. Let's open up the schema.prisma file, and we'll make some changes to the top here. We're going to enter the direct URL as well, and this is optional for better performance. If Prisma needs to bypass Accelerate, it can go directly to the database itself. The next thing we'll need to do is back in the terminal, let's npm install at prisma/extension-accelerate. And then in our library file, prisma.ts, we want to import our Prisma Client now from /edge, and that is going to help us in our serverless environments, which we are running in Next.js. And then also we'll import with Accelerate from that Prisma extension Accelerate. And lastly, we'll extend Prisma Client with the Accelerate extension. Now back in the terminal, let's npx Prisma generate, and we're going to pass the no engine flag, and this will regenerate our Prisma Client. And the last thing that we need to do is go back into MongoDB Atlas, and we need to go to network access. And because we're using Accelerate, we now need to allow access from any IP address unless you were to specifically set up a static IP address in Prisma Accelerate. Since we don't have a static IP there, we need to enable all IP addresses. So go to add IP address and then allow access from anywhere. So it should be 0.0.0.0/0 and confirm. And now Accelerate has access to our database with our connection string. So with this setup, our application now benefits from faster cold starts. Prisma Accelerate handles all of the connection pooling stuff, so you don't get those slow database connection times when your serverless functions spin up. You get better global performance. Your queries go through the closest edge location, making things faster for users all over the world. And there's no connection overload. Your database stays protected even when you get traffic spikes. You get smarter caching. Data that gets accessed a lot can be cached at the edge, and better visibility. You get a nice dashboard in the Prisma data platform that shows you how your queries are performing. So let's test the application again. npm run dev, and let's go back to localhost 3000, and it should work exactly the same as it did before. So let's add another user, test at test.com, first, last, and create user. And we have another user. Now to really see the difference, deploy your app to Vercel, Netlify, or AWS Lambda, and you'll notice way faster cold starts and more consistent performance overall. And next, let's take a look at some Prisma Accelerate caching strategies. So it offers edge caching capabilities beyond just connection pooling. Prisma Accelerate supports two main caching strategies: TTL, time to live, and stale while revalidate, SWR. So TTL caching works well for data that updates infrequently. You can specify how long in seconds a cached response remains valid. So in this query here, get users, we could add TTL in here. So we're going to add our cache strategy and then TTL of 60 seconds. So the cache is going to be fresh for 60 seconds. And then we can actually tag this as well. So user list. And we can use this tag for cache invalidation when needed. So with a 60-second TTL, the first request hits the database and caches the results. Requests in the next 60 seconds come from the cache. And after 60 seconds, the cache expires, and the next request then queries the database again. So this reduces database load for frequently accessed, relatively static data. So if we go down here to the get posts action, we can add SWR caching. And this works better when you need quick responses while maintaining data freshness. So here after the limit, let's add our cache strategy. So SWR, we'll set it to 120. So it's going to serve stale data for up to 120 seconds while the revalidation happens. And then again, we can tag this as well to invalidate it when needed. So with SWR, after the initial caching, any subsequent requests will receive cached data immediately, and then a background process will update the cache, and then users get fast responses while the system updates this stale data. And we can even do a combo. So after this count, we could do a cache strategy here of TTL 30 and SWR 60, so it stays fresh for 30 seconds, and then it's stale for another 60 seconds while it's revalidating. And a pretty nifty trick here is in the tags, we can add some dynamic tags here so that we can make these user specific. So this approach provides fresh data for 30 seconds and then the stale but fast data for another 60 seconds while refreshing it in the background. And then when data changes, you can immediately invalidate the cache using those tags by doing something like this: await, Prisma, accelerate, invalidate, and then pass in the tags that you want to invalidate. And that will cause that revalidation immediately. So to choose the right strategy, consider these factors for your application. Update frequency matters. For frequently changing data, use a short TTL or SWR. For relatively static data, a longer TTL is good. And then how current does the data need to be? Critical data, like financial data, could be short or no caching with invalidation. Moderate importance, like maybe social content, use SWR for balance. If it's low important, maybe it's just some data that's referenced sometimes, then longer TTL is fine. And then what is the access frequency? If there's a lot of reads, cache as much as possible. If there's infrequent access, then less caching is better. And these caching parameters can improve your application's performance without complex caching infrastructure. And that's it. We've built a complete Next.js application with Prisma ORM, MongoDB, and Tailwind CSS. We've explored everything from basic setup to advanced features like Prisma Accelerate. A quick recap: Prisma ORM and MongoDB seamlessly integrate with Next.js. You get type-safe database access with Prisma ORM. You get intuitive data modeling with relationship support. And you get performance optimization with Prisma Accelerate. Prisma ORM gives you a more productive, type-safe way to work with MongoDB that lets you focus on building features. If you're building with MongoDB, I highly recommend trying Prisma ORM today. Drop a comment if you have questions about this setup. Now, if you want some homework, here's a bonus. If you want to explore this stack further, I've created a GitHub repository with all of this code, the exact setup. Try adding more functionality like the ability to delete users, posts, and comments. Let me know what you come up with. If this video was helpful, give it a like and subscribe for more content like this.